At a glance, we will follow the process of Crosshole sonic log testing, which begins by inserting ground testing probes into pre-installed access tubes. This in turn creates a map of the shaft profiles, which will allow further analysis and report building. Finally, we are able to visualize the location and severity of these anomalies by using the tomography tool. Let's take a look at the first step of the process: data collection. CSL utilizes weighted probes, capable of both transmitting and receiving sonic wave signals. By analyzing the arrival time and energy of these signals, engineers can determine whether the wave has passed through sound, uniform concrete, or if it has encountered a defect, such as a void or inclusion. Anomalies in the path between probes will appear as delays in the arrival time, with lower energy. The transmission of the waves is visualized graphically as a line plot, where the x-axis represents the time and the y-axis represents the signal energy. When we take incremental measurements up a shaft length, we can create a visualization of the cross-section of the drilled pile shaft profile. However, this graphic visual of the line plot when stacked to create a profile is rather confusing to interpret. For that reason, we look at the waveform from above to clearly see the first arrival time. Because of its layered flowing appearance, the resulting CSL graph, which shows the ultrasonic profile of the shaft, is commonly referred to as the waterfall. The waterfall profile map is the key to CSL analysis. It allows us to identify anomalies in the concrete shafts. In a well-constructed shaft, the waveform remains consistent and uninterrupted, forming a smooth, layered pattern across the entire length. However, when a defect is present, such as a soil inclusion, the waveform is disrupted. This interruption appears as a break or distortion in the otherwise smooth, layered pattern of the waterfall graph. By analyzing these anomalies, we can pinpoint the location and nature of potential structural issues within the shaft.